Hello everyone, welcome to another video from Biology. So in the last video, we talked about how we can install Ray and then how remote function works. So in this session, we want to go through the actor model and see how we can leverage Ray for a better use cases. So what is the problem here? Let me give you an example. So far we've seen just a review from the last session. We've seen that we have a real parallel processing because we are creating different process, like different PID for each worker, and we are doing something there. But the problem is if I have a variable, let me have a variable here, like I have x, maybe another name, like var, which is 10, for example. And I just want to make the previous example somehow uh, to understand why we need actor model. So and then here in the high remove, every time we say increase var by the number and then print var, what will happen? Yeah. So I'm going to do that and see how it is going. So first of all, just to remind you, so we will have the vanilla call. So if I do this, so I know that every time I will call this would be just increased by 1 because we have a general global variable. Here, let's see what happened. It said local variable var reference b for assignment. So that's exactly what we want to see here. So there is no observability for this high remote function because like this function would be inside another process and there is no definition of var there. And we don't have um, kind of variable like the atomic or stuff like that that we can define it here, and every time different PID can increase it, So we don't have any state actually. And what is the purpose of actor is exactly defining a state. So I'm going to remove this, and also I'm going to clean this cell. I forgot the hotkey there. But what we want to do is creating actor. And what is actor exactly? Let me bring an example actor model. Oops, actor model programming. I want to look at images. Yeah. So yeah, this is a good example. So when we have actor, each actor has some state and they can send messages. So for example, in this case, an actor 2 is receiving a message from actor 1 and processing that message. It also can get a message from another actor like actor 3, and also it can process message B from this actor. So we can create a stateless or a stateful program, depends on the application we want. But here we have some state here saved for the actor 1, some state here saved for actor 2, and some state for actor 3. And we should have like a general state somewhere we update that state, because actor 1 is maybe just an example. Maybe you are doing a scaling and you have like 10 example of actor 1 sending a request to the 10 instance of the actor 2. So they should be a shared state there. But we will go through that. First step is just creating an actor, like 2 actor, and see how they can do the message passing. So yeah, another thing that it's cool is that the actor can create a child actor, depends on the need. So it would be like some kind of scaling based on need. So for creating an actor, let me come here. I'm going to call this like actor model. Okay. So what we're going to do is creating an actor. And for creating actor, it would be very similar to this, what we've done here. But instead of defining it on a function, we need to define it on a class. So if I have a class, for example, and I call it, because I want to bring example about like machine learning. Maybe I can bring an example about like uh, classifier model, for example. Yeah. And just an example, this is an abstract example. I don't have any idea what I want to do with it, but so far, so if I define like any class definition in Python, we define the initialization function. And for example, that classifier model, maybe it's getting some pre-processing and then apply the inference function and then post-processing and return the result. Maybe if we suppose that, so in initialization, we don't have anything like doing some fancy stuff except like loading the model. And I just want to mock them. I don't want to load any model for now. We will reach to that point. But for now, let's make it simpler. And suppose that my classifier, self.classifier is like, what I can define is a function, for example. And that function is like, let me see how can I define it. So maybe everything like bigger than 1, it's gonna return 1. Other than that, return 0, yeah? So what we can do is we have a lambda and we get an x, and yeah, if x is bigger than 1, yeah, we are returning 1, else we're returning 0. I'm not sure I'm doing it right. We will debug it and we will find the problem there. So yeah, so this is our classifier, for example. So what we want to do is, for example, we have a class called pre-processing. Okay, and again, it is getting a self parameter and it needs to get input. So I call this input. Because input is a reserved variable name, I'll just use input underline. And the output of this would be, for example, the input is, I don't know, it should be integer, yeah? So actually it should be int. The output should also be int. And what I want to do with that is, I say, for now, we don't have any pre-processing, like, this is just a simple example, just return input multiplied by a factor, something like that. This is really a mock example. Then we have inference, like infer function, that again, we get input, and what we want to do with it is we apply self classifier on it, and we apply input, and we return this. So the output would be integer. Yeah. And maybe we have a post-processing, post-processing. And what we will do with it is, again, we get input, and the post-processing, for example, we apply any function like softmax, stuff like that, I don't know. But let's make this again simple, and we will have this input. And just to be sure that we are calling the right function, I'm just adding some print. We can use log, but for simplicity, I say pre-processing. Let's say this is inference and this is post-processing. Okay. Suppose this is the class. So by defining this, now we are creating an actor. Yeah. So what is the use cases of this and how we can use that? So if, for example, we know that in Python we can do something like this, and based on this we should have the classifier. Yeah. Let me do that. So yeah, I made a mistake here. It's an invalid syntax. Yeah. My comment search a little bit about it. Yeah, sorry about that. I haven't used this for a long time. Yeah, maybe we can make it better. Like we can say 1 if x is bigger than 1, else 0. Yeah, comprehensive instead of one. Maybe Python doesn't have it. I think it had. I don't remember it. So my bad. So let's do this. So now it said actor cannot be instantiated directly. So if I remove this, okay, it said x is not defined. Yeah, x is not defined. So we need to define lambda. So for updating that, we need to have lambda x again here. I removed that part, but the rest would be same. Yeah. So let's do this. Okay, so it seems that it is working. So if I do something like classifier, let me have another function run, def run, and it will get self and input. And what it is doing itself pre-processing. Yeah, that is the pipeline. So we will get input, then we will apply self infer. We call this out. I will put this here and override it. I don't care about the result of each step. And again out or return the self post processing. And again out. So if I have something like this and I say run like by 2, okay, if I do this, so we will see that all of the pipeline will be run. But as I said, if I want to have actor, we need to have ray.remove there. And by doing that, we are creating an actor simply. And what is the use case of that? So, for example, I can do the similar thing, but instead of like just doing classifier model, I need to say classifier model remove, and I pass initialization here. I don't have any initialization, so that would be it. And the output, I think it's better to call it like actor to be sure that this is an actor. Yeah. And then by calling that, we have initialized the function. We have initialized the class actually. And for calling one of the function there, what we can do is we can say classifier actor that function, for example, run. Yeah. And removed, because remember that for calling them we need to call removed. And now, like by passing 2 here, I have run it. Let's see. So we have an object reference, everything is run, but we don't have the result. Like if I get the output here, and let me run it again. So if I have output here, I don't get anything from it. It's just a reference object. So for getting that, I need to say like ray.get, like exactly what we've done here. We have the remove function, yeah, and then on top of that we say ray.get. So we need to say ray.get. When we apply this, give me this, and at the end we'll have the result, which is 0. So what is the difference when I call this as an actor and when I didn't is that now if I call this, it will create a PID, like a process for me. And so far nothing, just defining an actor model. Then I define this and I say run, it will be run on a different process. And the cool thing about it is that it has a state, and that state is there. Anytime I call it again, it would be there. So as an example, let me give you an example. So if I pass remove 2, what happens? So I have 2 multiplied by this number as a pre-processing, and still it is not bigger than this. So if I return 3, I should get out 1, yeah? So let's have a state there, like the pre-processed value, yeah? And every time it is 0 unless we fill it, yeah? Suppose we have something like that. And instead of doing this, now I'm going to have self-preprocessed value, and I save that intermediate state. So that is an state, yeah? And I will return this as the preprocessed value. I don't need to because I already have that state. Like every time I can just self this and don't return anything. So I need to remove this, but just for simplicity, let's do it. So if I have this now, and I call it v2 again, okay. So I know that the out is 0, yeah? But what else I can do is that I can say, hey, actor, what is the processed value? Yeah. So it said has no attribute preprocessed. Oh, I didn't run it. Preprocessed value. Is there any? Okay, everything sounds good. So I can say let me check about the accessing gray actor model variable, you know. Okay, yeah. So we cannot access to this value directly. We need to define like get preprocessed value, I think. Yeah, based on the documentation check I'm doing now is like every time we want to get a variable, I think we need to define a get function for it. That's why maybe defining this as a pydentic makes sense because pydentic it's defining those get and setter and getter everything there. Let me search about it more a little bit. Maybe I can find something to get the state. Yeah, seems we cannot access to the state directly. We need some function. So let's do this. So we need to have like def get preprocessed, yeah. And when we do this, we just return the self preprocessed value. Okay. So if I define this again, and now I say get preprocessed value, and I do this, and again we need to have like ray.get. We will get that value because the state is there. So we pass through there, multiplied by this number, and we have it. So we have saved this as a mistake, but there is a problem still. So we have that class here. It is there until we say remove that, or until the scope of this variable is done. So for example, if we have defined this in the function, so when we go out of the scope of the function, we don't have this process. That process is killed automatically. If you want to keep that, there are some way to keep that. So let's talk about that first. So one of the way of defining this class is, as I said, is saying classifier and remove, and we create an actor from that. But there is another way. When we define this as array.remove, what we can do instead of remove here, we can say options, and we have different option here. We can set a name for this actor. Like currently the name is classifier model, yeah? We can say classifier 1, for example. And then I say like call that remove function with the instantiation, yeah? Now if I run this, what is the difference is that this classifier model, which is coming here, has a name. Let's see that. I'm not sure I can check this with name. No. But what I can do, maybe there is another way, but what I can do is that when we say ray, because we have created some actors so far, yeah? When I say ray that get actor, Okay, it not working, it missing name. So we need to pass a name for it. So we can say name and give me the classifier one. Okay, so now we have that actor. So what is cool about that is that when we define, for example, in a different part of the project, we are defining all of the actors, and we want to just call like like find an actor and its like features or calling some of its function with the name. Yeah. Previously, if I didn't define a name, how could I find this unless I have the variable here? But now I am able to get that variable. So definitely this would be like same. Yeah. I say Ray, give me that actor with this name. But this is not the main reason. Let me not delete that because maybe you want to have it. It was in edit mode, undo. Yeah. So maybe another cool thing I want to talk about, the options here is not just for name, but it's also for lifetime. As I said, the lifetime is based on the lifetime of that object. Is object that your actor is dead. But you can define lifetime, and by defining lifetime, you can say this lifetime can be detached, for example. So when we say detach, it means that the actor can persist even after the driver process exits. So even when we go out of the scope of the function, and even if we go to another file, still the actor exists there. And this is cool because in another part of the program, we can get that actor. We can delete that or kill that. I will talk about how, but yeah, we can do that anyway. So by defining lifetime and say this is detached, okay, I think there should be some way like actor Ray get status, like getting the status of all actor. Yeah, there are some cool definition here. uh, no, I don't want to go through that pass yet, it is too soon. But seems like we can say Ray summary actors. I haven't checked this. Let me see. Is this implemented? Okay, yeah, we will talk about dashboard. Yeah, we don't have a dashboard yet. So at the end, we will see that all of the actor we will create, we have a UI there. We can see all of the actors, the how they are working, stuff like that. So when we do this, it would be persist until we kill it. And for killing that, we can do two things. Like by ray.actor exit actor. Let me give you an example. Let me delete this. So we can say ray dot actor. Yeah. So this is like a module inside ray actor, and we can say exit actor. And what is this? It's saying that intentionally exit the current actor. Yeah. So if we have a current actor, it would be intentionally delete that. This API can be used only inside the actor. Use ray.kill API if you'd like to kill an actor using actor handle. Okay. So it's better to use like kill instead of this one. So we can say kill, and how kill work is that we can say this is the actor handle, and no restart is always true. So how we want to do that is first we need to get actor name. So we need to have the name of it. So we get this actor and say kill this. And what it's doing now, it's killed. Now if I again want to get that, it said fail to look up actor with classifier 1. This could be because you are trying to look up a name actor you didn't create it, a name actor died. We did not use namespace matching the namespace of the actor. Yeah. So everything sounds good, yeah? Let me bring this code up because this not belong to here, it does belong to here, sorry for so I'm just writing this should not work. Okay, because we have killed it. So far so good. So we have understand what is actor, how we can call that. So far how we can make it like persistent for all the time, like persist for all the time to not die. Yeah, but there are other things that we need to be careful about it. So one of the things is that suppose I have this, let me bring another example here. I have this as a classifier and I have another one, classifier 1, classifier 2. Maybe I want to have like a 2 instance of this. Yeah. So classifier actor 1, classifier actor 2. Sorry, my iPhone, my Siri detected I said Siri. I don't know why. So let's check this. So we have these two. So it said it looked like you are creating a detached actor in an anonymous namespace. In order to access this actor in the future, you will need to explicitly connect this namespace with Ray. Oh, cool. I didn't know that the namespace. Let me also check about that namespace actor Ray. What is that? Namespace is a logical grouping of job and name actor. When an actor is named, its name must be unique within the namespace. In order to set your application namespace, should be specified when you first connect to the cluster. So when we say Ray init, we can define that. Yeah. Okay. Okay. Yeah. We will talk about all of this later. So far, let's do what we have. So if you remember, we didn't use like Ray init, stuff like that. We just import Ray and we just use that so far. So we haven't connected, but this is okay. We are on the same namespace, the original namespace. So what I want to talk about is if I, for example, let me give an example. If I call the classifier actor 1 with this value, so I have out 1, and I do the same thing but with value 3, which will return 1, I think, and I call this 2 with actor 2. Okay. One of the other things is that name is already taken, so we need to define a different name. That's the error that we got if we use the same thing. Yeah, so let me bring this down. Bring this down, and I call these two. You see that these two are called with different process ID. And let me clean this cell. Okay, we have defined them, we have called them. So now, if I get, let me do this after calling Operation. So if I say classifier actor 1, give me the value and just print it for me. This is the preprocessed value there. And do the same thing. Yeah, we don't care about output ones, we just care about the intermediate value because that's the state you're looking for. So let's see. So for the first one we have this, for the second one we have this. Yeah. So for some use cases that's okay because, for example, classifier should work differently. But suppose we have written some pre-processing function that needs some shared state between these classes. Like for example, I have a variable here that over time it should be changed, like how many files you have read or stuff like that. And you are keeping that, like how many times this is called or stuff like that. And you are keeping this here, but the value here is different than the value there. So you need to like share these two. So that's when we call actor persistent. That means that like using a database or using a file system, we try to persist that data, persist that state. Yeah. And for persisting that, as I said, we need to store it somewhere, like using dumps, pickle, or stuff like that. So Ray had some functionality, Ray Cloud Pickle, and let's see how it is going. Yeah, Ray had Cloud Pickle. Let me search about it because I don't wanna. Yeah, let's see the difference. Uh, yeah, I really don't know what is the Ray Cloud Pickle. Let me search about it a little. So actually, Cloud Pickle is a Python library that convert byte stream and deserialize it, including function classes or distributed computing. So if you use Pickle, you need to have like a serialized object. So by Cloud Pickle, you might wanna send Python function or object across the cluster of machine when Ray is running. So Cloud Pickle offer powerful serialization capability. It might not be as efficient as a standard Pickle, but one of the problem with the Pickle itself is that we need to serialize everything before pickling them. Yeah, but Cloud Pickle has handled some of this. So Ray had Cloud Pickle. So every time you wanna store something, you can do like ray.cloudpickle dumps and store that information. Yeah. So let's give an example, but we wanna do the correct design pattern. We wanna have the correct design pattern here. So when we wanna have persistent actor, it's better to create a class as a base persistent, because persistence, because the thing is we wanna inherit like give these properties to any actor if you want to make them persistent. So it's good to have a design pattern here, and the design pattern offered by the book I'm reading, as explained in the first session that we had, is first having a function called exists, and we will create a key value dictionary, and for that we are getting a key. The key can be a string, and as an output we are saying just this is exist or not. Yeah, and we can define like abstract class, but here I'm just making it simple, just creating this way. So another function is save. We need to save that key and value. So we have a key which is a string, and we have a data. I can't say this is dict because we want to have a different way of saving. It doesn't return anything. And then we have the restore, and the restore, when we pass key, so when we pass key as a string, it wanna return us a dict. Yeah, this is the whole pattern that we want to follow. So what we want to do with this function, with this base persistent, so it's better to have different persistency. Like this is like a hexagonal architecture. You have the SQL, maybe you have another database, maybe you have file storage, maybe you have a dummy persistency. So for that, for now, I'm creating like a file persistence, and file persistence is inheriting from base persistence. So by doing that, we are saying that file persistence should implement this function. Yeah, if you want to like force it, it's better to use abstract function here. This is just for our tutorial about Ray, not about Python. So first of all, we need to define the initialization function, and what I like to have here is a base directory. So the base directory means that where we want to save that information, and that would be an str, and the default would be here. Yeah, and then I just want to save that base directory. So base directory. So now we need to define those three functions I have mentioned here. So let me copy and paste them. Okay, and let's implement them. So let's start with saving. Yeah, so we get key and data. And as I said, what we can do is using Ray. So we have cloud pickle dumps, and we can dump that data, like convert it to some bytes here. So because bytes is like keyboards here, just bytes underline. And then we want to save it with open in a file, and that file can be there are different ways to doing that. Like we have a folder completely saving each file there, or maybe we want to have only one file saving them with some indexing. I don't want to do that. So what I want to do that is we get the self-based directory, and then we can use join, or maybe just simple string. It is not optimized, but like let's do this. And then I say use the write and binary, because this is binary, and at the end we want to write this bytes. Yeah, so far we have saved it in the name of the key that we get. Now we have some bytes. Of course, this is not optimized, we are not zipping it or stuff like that, but this is fast. Then for restoring that, very simple. First of all, we need to check that it is exist or not. So if self.exist, that key, we say just nothing. So no. Otherwise, we want to open that file. So I'm going to copy and paste this, but this time I want to open it, so I don't want to write it. So I want to read it as if, and I just want to say if.reads read, just read all of the byte there, and it's get bytes again. And after that, we need cloud pickle again. So I can put this as a return function here. So I say array.cloud pickle.loads, and I get those bytes, and that's it. And for existing, we can use the exist function. Yeah, so we can use return exist, because this need to be self-exist. That exist is like for Python. So we can say if this is exist, I'm not writing it again, or we can use OS exist, stuff like that. So that should work. So we have this file persistent. Now, if I want to make my actor persistent, let me have this. Let me copy this here. I need to update this function a little bit to make this persistent. And what I can do now is, as I can do like inheriting it from file persistent. That's one design pattern. Another way is to injecting the dependency, which I don't want to make it complicated. Let's just pass it as like persistence, and it should always be from base persistent. Like we say, everything you pass here should be from base persistent. Always recommend to have type, because if I don't do this, how people know to pass what exactly to this kind of class? So in the future, if you want to implement like SQL-based persistent or S3-based persistent, for example, so we are able to switch it. So the cool thing is that now if I do self.persistent equal persistent, so every time if I want to save something, for example, every time let's see what we can make here as a persistent, what we need to do as a persistent. For example, if something is processed, why, like defining a caching, like if something is processed, why we do process it again? Why we need to process it again? Yeah, so what I can do with it is I come here, I say, maybe if you do post-processing, okay, let me think about it a little. Yeah, we can do that. So whenever I'm doing this serve persistent, I checked for existence, like I say exists, and the key would be the input. I'm going to convert this key to a string. That input can be converted to a string. And if that not exists, if not exists, I'm going to save it. Yeah, but the better way is to like have it here in a run function that then when I get an input, instead of going to all of this, if that exists, return it. Yeah, so I'm not implemented here, but let's have it here. Every time I get an input, I check that. If it is not exist, I will go this fast. So if it is exist, so if it exists, what I'm going to do is I want to do self dot, oh, what is the problem with the indentation? Self dot persistent, and I use this function restore, and I do restore, and I will get, again, let me have this as a key. So this is key. Okay, so if we say this key exists, give me that value. And we said that this should be like for saving that, we need to have like a dictionary type. So that should be a dictionary. So from that, I want to get value. Yeah. So for if it exists, so we're gonna just return the value. But other than that, if it is not exist, I wanna create this as an output. I don't want to return it here. Yeah. And I'm going to save it. So I use self.persistent, and we are going to use save with the key that we have and the value, like the dictionary that we have. Value would be equal to out. Yeah, this is cool. Okay, and at the end we want to return. So what we have done is like implementing a caching based on the actor persistent. So how that work? Let me give you an example. Okay. I want to create two actor, like the example that we had, like these two. And I want to change this classifier model to persistence. Okay. So let me also copy and paste this too. We can define as many number as we want for number of actors. Here we are going to create classifier persistence. and we have two actors. Classifier one pairs. That's just something to be not similar like what we had. And yeah, name is okay. We can override it. We will lose this, but we can use the get to getting that. And I want to call that function like we want to have, where is that function I used that? We want to say run. Yeah, we want to say run. Where is run? Okay, yeah. So we want to run it and get the output for both of them. So what I want to do is also print like reading from cache. Yeah. So here we say that this is read from cache. Let me have this space persistent is not defined yet. We haven't called this. Let's define this. So we have some error missing required parameters. Oh yeah. So now we need to define like paths that file persistently. So we need to say persistent is equal to persistent is equal to this. Same thing. I can define it once. So file persistence. Let's come here. We don't pass any variable to it, so that is file persistent. Similar thing here. It shouldn't make any problem now for us. And as I said, for getting the output. So this is from the first one, from the second one, but this time I want to have exactly the same value and get the output. Output 1, output 2. And we have the print function. Maybe that print function is enough for us. But let's try it. So we have those classifier, we run it. It said what? It said name exists is not defined. Yeah, I think this is the part I was not sure about. It exists. We need to define it somehow different. I think there is the OS as exists. OS pass that exists. OS pass that exists. We need to import OS, then say OS pass that exists. Let me do that. OS the pass that exists. Okay, cool. Let me do that again. It will say that you have this, you need to kill them. Okay, or you can use a different namespace, like giving an example when we say get actor, we can do different namespace. What I want to do is I want to restart everything so I don't have any dependence. Okay, and then let me have also Ray here. Just important to not wait for the other. So still that 10 seconds is running, I think, here. So now we have actor, and if I say run, you see the first one is run. The second one, of course, it is from a different PI, but it is reading from cache. It's not going to the whole process that we had. So this is persisting data between different actors based on the file system. So what is cool about that is that, like, if we have model saved somewhere, we want to have different actor access to that model or save some data or like contribute to each other. We can use this kind of persistent. There are other ways. I will talk about them in the next session. I don't want to make this video longer, but we can create actor pool, and based on actor pool, we can now like say all of this pool is persistent over like this file, for example. Or we can create threaded actor. Each actor is even can be like multi-thread application. So that can get complicated. Bear with me. We will have lots of fun together. Thank you.